All right, everyone say hi to mom and dad.
No.
No? How sad. So here we go. A farmer has 1,600 yards of fence, okay, to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So what am I looking for? The dimensions. Dimensions means what, y'all? Dimensions means what? Length and width. Oh my gosh, yes, length. Width. You're right. I'm going to box it up because I know that's what I will need to find in the end. So tell me how to execute this. What is it? Write the perimeter. You are correct. How do we write the perimeter of a rectangle? 2x, what else? Plus 2w. What should this whole perimeter equals? Perfect. Okay. I'm really not interested in perimeter. I'm really interested in what? The length and width of what? That would make what? The maximum what? Area. Okay. So I want the largest area of this rectangle. So what do you do here? Would I need another equation for area? Sure. Okay. Area equals what? Length times width. Okay. It will be really difficult to solve one equation with two variables. So you're going to have to rewrite the area formula. In terms of you pick either W or L. You get to choose. What would you like to rewrite it as? Okay, area in terms of W. That means I'm going to keep my W. That means you have to find L to substitute it in. Where would you find it from? Conveniently, from where? From the perimeter formula. Okay. Oh, I'm not using, can I just use X because X is already there? Is that okay? My bad. Okay. So we're going to find X from our perimeter. Here we go. You're going to solve for X. So I would say 2X equals 1,600 minus 2W. Is that still okay? That means 1X is what? 800 minus W. And now, can I substitute that in here? 800 minus a W. Okay. Now what are you going to do to find the length and the width of my largest area? Bust out your calculator. Graph it out. Be mindful of your window. You can't have too big and you can't have too small. If the window is too big, you have this flat line, you're not going to be able to trace the maximum. If the window is too small, you can have one straight line, which there's also no maximum. So punch it in. Let me know. Let me know your best window with those of you. It's good to kind of mess around with the calculator to know what's working for you and what's not working for you. I can totally help you if it's not working. Again, if your window's too small, you're just going to have a line, and that's not going to be applicable. Make sure you have a normal window. If your window's too big, you're going to have something really funky, something super skinny. Your window looks beautiful. What is your window?
0 by 800.
So X min, what was your X min?
0.
0. What's your X max?
800.
800. Okay. So that's what he got, and it looks really good. Once you enter in X min and X max, can you hit zoom fit? Okay. Once you enter in X min, X max, hit zoom fit.
Not working.
Go back to your Y equals. Let's double check your Y equals. 800x. Okay. Go back to your window. You need to do zoom fit. So hit zoom and zoom fit. There you go. Anyone else having problems with the calculator? Okay, you got something. Oh. No, it does not supposed to look like that. Let me see your window. Okay, zoom fit. You need to do zoom fit. So once you enter X min, X max, you hit to zoom. Go hit zoom. Right there. Right there, right there, right there. And for zoom fit. So go all the way down. You're welcome. Anyone else having trouble? You need to unhighlight your plot, so go up. Enter. Okay. And then, okay, you need to hit zoom fit. Did you enter in your window? X-Men, X-Men? Hit zoom fit.
Yeah, I hit zoom fit.
Your X window is not big enough because right now it's not giving you any max. So, you better try zoom fit. You keep doing.
I did zoom fit.
No, every time you change the X window, you got to do zoom fit again.
Okay. So
Closer. Okay, let's try a bigger X window and then zoom fit again.
All right.
Does that make sense?
Yeah.
Yeah. Anyone else having trouble? Is it a parabola? Yeah. Is it upside down?
Yeah.
Yes. So now what do you do to find my answer? The max. All right. You're going to hit second trace, max. It will give you, be very careful. Okay, so most of you have a graph that looks, yes or no?
Yes.
By the way, if I asked you to sketch this out, what would you label the X? Your input, X-axis? The width, because I'm using W. Can you see this? If you're doing A of L, then that would be your L. Okay, so this is your width. What would you label your Y-axis? Area. Okay, so be mindful when you're using your calculator. So, right away, your calculator should give you the width. What is the width? 400, what's a unit of measurement? Yards? 400 yards. Now what? How did you get the length? Plug it in. Sounds great. Plug in where? The perimeter formula? You are correct. Can you also, on your calculator, when you do the trace piece right here, class, can someone tell me what that calculator gave you, the order pair that they gave you? 400 comma what? 160,000, like that? Someone tell me, what is this? Oh, my bad, thank you. Someone tell me what that is. What is this right here? What? You have the area, you have the width. How do you go about finding the length? That's right. Okay, just take the area divided by your width. That will totally give you your length. So 160,000 divided by 400 yards equals 400 yards, which is also the length. If I said, what is the largest area you can create? Your answer would be? Yep, and that's very likely that you will see on an exam, so make sure you are mindful. Okay, ask me now on this question. Going once, going twice. I'm going to go up a little bit. Can you help me read, Daniel? Can you help me read example 3, please?
Projectile is fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal, with a muzzle velocity of 400 feet per second. In physics, it is established that the height h of the projectile above the water is given by.
Yes, sir.
Okay. H of x equals negative 32x squared over 400 squared plus x plus 500, where x is the horizontal distance of the projectile from the base of the cliff.
Perfect. Thank you so much. So okay, if you can see that the 500 is already taken into account, right? Okay. So A, find the maximum height of the projectile. What do you do here? Calculator or non-calculator? Calculator. Plug it in. Sure. Ask away.
Could you square to get 1600? Or
Yeah. You can totally square the 400. You can enter it however you want in the calculator. make sure you know how to adjust your window. So that will give you a nice graph. Now, if this question is asking for the maximum height, what are you expecting your calculator to show? A parabola, opening up or opening down? Down. So make sure your calculator needs something like that. Especially if you're taking a test and you have a line, obviously something is funky. Okay? So fix your window. Understand how to fix your window. Bless you. Bless you. Should you have any negative x value on your calculator? What is the x value? What is it representing here? What kind of distance? Horizontal distance, right? So should x be negative at all in your calculator? No. Bless you. So when you have a nice graph, raise your hand so I can write down the window. Anybody has a nice picture in their calculator yet? What's your window, Dominic?
X min 0, X max 1000,
X max.
Y min 0, and then Y max 1750.
I think when they enter X max, Dominic, bless you dear, they can do zoom fit and get the Y's on now. Bless you. All right. Who's struggling with the calculator part? There you go. You guys getting it? Because Dominic gave you the X min and X max, you can just hit zoom fit. Okay. You don't need to mess around with the Y values. All right. What should we label the x-axis in here? What should we label the x-axis? Horizontal distance. Sounds good. What should we label the y? The height? Do we start at 0, 0? Nope. 500, right? Something like that. Is this going to eventually hit the ground at some point? Yeah. Okay. So find the maximum height of this. So maximum height is and the unit of measurement for this question is what? What's the unit of measurement? Feet, right? Okay. Raise your hand when you have an answer. Okay. We have a couple. Some of us are still working. That's okay. Thank you. We'll wait for a few more minutes because not everyone's quite here yet. If you are ready to do B, go ahead and do B. Remember, I don't need an ordered pair for max height. I need just the answer and only answer. So don't give me an ordered pair for this part. So max height is, okay. Ashley B, what's your max height, dear? 1750. So 1,750 feet. Someone confirm that for me? Yeah? Okay. Part B says, how far from the base of the cliff will the projectile strike the water? What am I looking for?
The X.
The X. When?
Y is 0.
Y is 0. Okay. So 0 equals negative 32x squared over 400 squared plus x plus 500. By the way, can I just trace it on my calculator?
Yes.
Yeah. You can totally trace this point right here. Can you see that right there? How do I trace that? What button am I going to press on my calculator? Second. What?
Second trace 2.
Yeah, second trace 0. It's going to ask you left bound and right bound. Where would the left bound be if I'm tracing that point? Top or bottom? Top. This right here is your left bound. And then down the bottom somewhere is your right bound. Okay, right B.
So
Daniel?
like if we were answering this question on like a test or quiz or something, thing, how would we show the work?
A lot of these are you don't have to show anything on the paper. A lot of it can be done just on calculator. But then that's another thing too. There won't be a lot of partial credit if you don't have anything written down. Okay. So what you want to write down is, you notice how like I'm doing that right there? You might want to do that. At least I know that you understand the height is 0 when it strikes water. Okay. How far when it strikes water? 5,458 feet. Oh, 0.04? 0.04 from the base? Feet from the base when it strikes water. As you can see, they're all calculator. Okay. Any question on those at all? Easy so far? Yeah, all calc, min, max, optimization. Okay. Calc BC kids are so excited right now to do optimization again. You know, the calculus way. Here we go. 2 more examples and we'll call it a day. All right, Samantha, can you help me with example 4, please?
The Golden Gate Bridge, the suspension bridge, spans the entrance to San Francisco Bay. Its 746-foot tall towers are 4,200 feet apart. The bridge is suspended from 2 huge cables, more than 3 feet diameter. The 90-foot wide roadway is 220 feet above the water. The cables are parabolic in shape and touch the road surface at the center of the bridge. Find the height of the cable at a distance of 1,000 feet from the center.
Okay. So find the height, so that's what we're trying to find here. Find the height of the cable at a distance 1,000 feet from the center. So here's where we are. Okay. Okay. How would you attack this on a test? What would you need? Daniel?
The equation.
I would need an equation of a parabola. Let me remind you 2 different forms of the parabola equation. Y equals ax squared plus bx plus c. That's one of them. And then there's the other one that we use the vertex form. So x minus h squared plus k. That's the other one. Okay. Let's identify some key points first. Do we know the vertex? What is the vertex? Okay, 0, 0. I need a vertex and another point. Do we have a second point? A point? What point are we going to use for this one? Wait.
5.
Okay, so 2100, 526?
Yeah.
Okay, 2100, comma, 526. So if you look at this, which one's easier to use, the first form or the second form? Second form? Because h and k are both 0. Okay, so sounds good. Y equals a times, since h is 0, can I just say x squared? I need to find a. How do you go about finding a? So I use this already. That's what we need a second point, right? So now I'm going to plug in what for x? 2100 square, yay, nay? And then y is going to be 526. Divide both sides by 2100 square. So a is going to be 526 divided by 2100 square. I'm going to keep it as square because I don't want to write a bunch of zeros. Now what? Now do I have a real formula? Y equals a is 526 divided by 2100 square times x square. Is that okay for our formula? Okay, what are we looking for again? The height of that cable when now what are you going to do? Plug it in. Okay, here we go. The height is times 1,000 square. Okay, plug in calculator. Approximately how high is the cable when you are 1,000 feet away? Mm-hmm.
I got 119.27.
119.27. Someone confirm?
Yeah, that's right.
0.27, Kara?
Yeah.
Thank you. Okay. So the height is 119.27 feet. Okay. I'm going to wait for you guys to ask questions because sometimes it doesn't come in until later. If you have questions like, hey, what happened there? How did you go from there to there? Let me know. Anything that wasn't clear? Go once. Go twice. Okay, last one. Do you guys remember this from Algebra 2? Scatter plot? Kinda? Yes? No? A farmer collected the data given on table 3, which is to the right of your notes packet, which shows crop yield, which is now Y, for various amounts of fertilizer used, which is X. So X is your independent. The number of crop yield depends on how much you use of fertilizer. With a graphing utility, draw a scatter diagram of the data. Comment on the type of relation that may exist between the variables. So I don't need you to sketch it out on my paper. You just need to put it in your calculator. How do you do that, by the way?
Second stat.
Okay, stats. Don't put it in, enter the list first. Do you guys see L1, L2 on your calculator? If you have stuff in L1, L2, can you please clear it out? I will help you if you don't know what it's on the class. Hit stats and then edit. There has to be an L1, L2. You guys see L1, L2? Hit stats and then edit. No, stats. Don't say the name. Stats. There you go. Which one are you going to enter in L1?
X.
X. Okay, all the independents. And then L2 will be your dependent. Once you enter that in, it says, comment on the type of relation that may exist between the two variables. What I'm looking for is, are the two variables linear? Are the two variables parabolic? Are the two variables cubic? Quartic? And after you enter in the data, someone tell me what else you press. Okay, so once you get there, let me know. And if you don't remember, or you have a worse memory like myself, then just write it down. Don't forget to look at the correlation first before you even run the regression, guys. Look at the dots first. Don't run any regression. You're going to run it wrong. Look at the dots first. How do you get it to graph a bunch of dots for you? Okay, you got the list in. How do you get it to graph the dots for you? You go to stack plot. Okay. Turn on plot 1. Okay. An easier way is, okay, I'm going to go back. Anyone not done entering the data? Because I don't want to repeat it. Not done with the data. I'll show you like a quick way. Yes, you can do what they did. Okay, go back to y equals if you're done with the data. This is a quicker way if you choose to do this way. Okay? Go back to y equals. Can you go and highlight plot 1 to go up? This is plot 1, y equals. And then highlight it. There you go. But don't run the regression because it gets a line in it. Line's not right. Okay, so highlight plot 1. Then can you hit zoom and zoom stats? Zoom and zoom stats. Do you now see a bunch of dots? Great. Is it linear?
No.
No, so some of you are already running the regression. It's not linear. What does it look like? Maybe quadratic. You're right. So do me a favor now, go run a quadratic regression to see. Anybody know how to get there? Like a quadratic regression? Stat and then? Yes, stat and how, and then go to not linear, there's one linear. When you run the quadratic regression, can you find R square value for me? What does that say in the R square value? 0.949. Let me tell you quickly about the R square value. Oh, if it doesn't show, that means you need to turn that in diagnostic. I'll tell you about it. I'll slow down so that way you guys can see. Can you run the regression? Yeah, great. Hit enter. Enter again. There you go. Okay. Okay, so some of you don't have the R square. Can you do me a favor and go to Parabola and turn on your diagnostic? Right now it's probably off. You have R square value? Yeah, you're fine. If you have R square value, fine. If you don't have R square value, find Parabola.
Is it diagnostic on?
Yes, hit that and then hit it twice. And then run it again. Now you just have an R. You are not doing linear. What shape does that look like? Right. What shape does the relationship show? Huh? Go back to the scatter plot. Go back to the dots. Where did it show the dots? Oh, go back to. Did you already enter L1 and L2? Okay, go back to Y. Go back to Y equals. Y equals. Turn on. Okay, good. Now zoom and zoom stat. Zoom. Stat. A bunch of stuff. Okay, go back to your list. Where's your list at? Why is your list flat? How did you do the list? Okay, you have the incorrect list. L1 can only be your X value. There's only 2 lists. Okay. These are just the number of plots, which is not your variable. So all you gotta do is this is your input and that's your output. So do that again. Again, because you're headed with a bunch of flat line. Anyone any issues so far? Just calculator. I'm just walking around to help you get the calculator calculation. Yeah, I'll let you. That means your lists are wrong. One of the lists has higher number than the other. So go back to stats and then go to your list. Okay, you have way too many things on your list. You should only have 2 lists. Oh, really? On this calculator? Okay. So go down all the way to the bottom and show it line up.
Let's do.
Well, number one, you have like 40 and 19. You know what I mean? Yeah. So make the X max a lot bigger. Yeah. Is there another list somewhere? Because I'm not an expert in my yeah. Yeah, let's keep it. Maybe your data's wrong. Go back and check the list.
I compared it to, I compared it to, I don't know.
Yeah, because oftentimes it's just the list that you enter in. So double check the list. But yeah, usually just double check the list. If your R square is incorrect, it's usually the list. Like you enter in like a one wrong number or something like that. Anyone else? And if need to, I'll come back and help you guys personally with the calculator. Okay. Okay, so A, let's answer the question before we wrap it up. A said, comment on the type of relation. What kind of relationship do you see? Linear relationship, quadratic relationship, cubic relationship? Quadratic, okay. Quadratic regression. Then part B says, use a graphing utility to find the quadratic function of best fit. This is where the A, B, C values come in, okay? So on your calculator, what was the A value? Let's keep it consistent to 2 decimal places. What was A? A was?
Negative 0.2.
Negative 0.02, so that's x squared. What was B?
1.08.
1.08, so that's x. And then was constant?
3.89.
3.89, just to keep it consistent with the class. Any questions on that piece? And some of you, I know 2 of you still have some issue with the calculator. I'll come over in a little bit. And use the function found in part B to determine the optimal amount of fertilizer to apply. What do you do here?
You plug that equation in and graph it.
Actually, is there a way for you to input it in straight up?
Yes.
How do you do that for some of us who remember from Algebra 2 trig? You should not enter this in like that. You need to use all of the decimals. So, you know when you ran your regression? So go back and run the regression. Where it says the button says variables or I think function. Let me see if I wrote this. No. Go back and run the regression. Okay. Where it says store? Where it says store? Don't run. Can you see store? Yeah. Okay. Hit. I want you to store in function, which is y equals sub 1. So find. I think it is. Okay. Where do you do it? Where it says store is where I want to have it. Store. Oh, I didn't hear it. Okay. I want it to be y equals. Okay, so there you go. Okay. So where it says regression, what button do you guys press to get your y functions? Vars. Okay, hit vars. Can you guys see vars? Okay. So hit vars, and then go to y vars. Are we still following? So hit var, go to y vars, and go to y sub 1. Okay, so hit function. Okay. And can you see like y1, y2? Okay. So if you want to store in y2, no big deal. Hit y2, hit y1. And then now hit calculate. It should now be the new y to 1 if you go back to y equals. Can you see that or no? Go back to y equals. There's like a bunch of decimals now. Okay. Then hit graph, and it now should put it in together for you. I'm going to come around again to see.
So
run the regression.
I saw the store, but then wait, so I go down.
It's store. Bars. Y bars. Okay. So once you do that, hit the maximum. Use a function found in part B to determine the optimal amount of fertilizer used, which is the x value. So what is the optimal amount of fertilizer? The optimal amount of fertilizer to apply is what? So based on your calculator, What is the number?
31.4
31.4, you said? Pounds for every 100 square feet. You're right. Okay. Then same thing. Use the function found in part B to predict the crop yield when the optimal amount of fertilizer is used. Would you agree that just the Y value on that table? So what is the Y value prompt on your screen?
About 21 bushels.
About 21 bushels, right? Okay. And I'm not going to ask you this on the test. Draw the quadratic function of best fit. I'm just going to write on calculator. Are you guys okay with that? Okay. I'm not going to ask you to plot out a bunch of dots. Okay, so that's an egg roll.